Hello everyone, my name is Olga and you are on the JavaRangers channel. You have probably seen this kind of screen when trying to log into a web application. Here you are asked to authorize using a third-party resource, Google, Apple, or Facebook. The OAuth 2.0 Authorization protocol serves this purpose. I will explain in simple terms what it is, how OAuth works, and show you how to implement OAuth 2.0 in a Spring Boot application. OAuth 2.0 is an authorization protocol that allows one service to grant an application access rights to a user's resources on another service. The protocol eliminates the need to trust the application with your login and password, and also allows for issuing a limited set of permissions rather than granting everything at once. What is the difference between an authorization protocol and authentication? The authentication protocol is OpenID. It is designed to verify that this specific user is who they claim to be. OAuth is an authorization protocol, which means it allows granting permissions for actions that our application can perform on this service on behalf of the user. Let's take a look at the main roles in OAuth 2.0. The resource owner is the user who has rights to the protected resources. This can be an individual or a system that owns the data. For example, a user who wants to grant an application access to their data in Google, such as their Google contacts. The client is an application or system that requests access to protected resources on behalf of the resource owner. The client can be a web application, a mobile application, or a server application. For example, an application that wants to access the user's contacts in Google. The authorization server is a server that is responsible for authenticating the resource owner and issuing access tokens to the client. The authorization server can provide two types of tokens: access token and refresh token. For example, the Google authorization server, which handles user login and issues tokens, and the resource server is the server that contains the protected resource and verifies access tokens. To allow or deny access to these resources, the resource server receives requests from the client and uses the access token to determine whether to grant access to the data. For example, Google Contacts, which stores the user's contacts and provides access to them only with a valid token. There are several OAuth authorization options suitable for different situations. I will tell you how authorization works for applications that have a server-side component. Most often, these are websites and web applications. The client sends a request to the authorization server on behalf of the resource owner. This request may possibly include a request to obtain an authorization code. The authorization server verifies the authenticity of the resource owner. For example, the user enters their credentials, and upon successful verification, an authorization code is issued. Next, the client uses the authorization code to request an access token from the authorization server. The authorization server issues an access token and sometimes a refresh token, which can be used to renew the access token after it expires. The client sends a request to the resource server. Attaching the access token, the final step. The resource server verifies the access token to see if it is valid. It provides access to protected resources for the client. So let's create a Spring Boot application using Spring Initializer. We will add the necessary dependencies: Spring Web and OAuth 2 client. We open it in the IntelliJ IDEA application. I forgot to add another dependency needed for working with the database. This will be Spring Boot Starter Data MongoDB. I plan not only to authenticate through third-party services, but also to save this user in the database so that I can work with them in the future. Now we move to the application properties. So the first line is the name of the Spring Boot application. It is used to identify the application in distributed systems. The following line is for connecting to a MongoDB instance that is located on the local server localhost and is listening on port 27017. The next line is the name of the MongoDB database that our application will work with. That the following two parameters pertain to the OAuth 2.0 client. This is the client ID and client secret for registering an OAuth 2.0 client with Google. This ID is used to authenticate our application when interacting with OAuth 2.0 with Google services. We will need to obtain this parameter from Google through the Google API Developer Console and enter it here. For now, I will leave it empty. This line specifically sets the logging level for Spring Security to trace. I am currently on the page cloud.google.com. I came here specifically to create an ID and secret for my application. I go to APIs and Services. I create a project. Click on Create. Now let's go to the OAuth consent screen. This is the so-called consent screen, the screen that will be displayed to the user when attempting to log into our application. What do we need to choose here? External, Create. Here we select a name, that is, the name of the client. I also provide my email address as contact information. Continue. We are now on the Scopes page. Scopes are the visibility areas of the Google resource that we request from Google. Let's add. So here I select email, profile, and OpenID. Continue. Now we are on the test users page. Test users are users who are allowed to use this feature as long as the application is in working condition and has not yet been published. I will add myself here. You can add up to 100 users here. Let's continue. Here, general information is displayed. We check and click back to dashboard. Now we simply go to credentials. Create credentials, OAuth client credentials. Here we select the type of application, web application. We write the name of our application. This is a setting used in the OAuth client to determine which domains can send authorization requests. Authorize redirect URIs. This is a setting in OAuth 2.0 that is used to specify a list of addresses to which the OAuth 2.0 server can redirect the user after successful authentication. Just remember that for Google, this setting must be exactly like this. Here, finally, we see the client ID and client secret that we received, and we need to insert them into the application properties. Now let's return to our application. We open the application properties and insert the two necessary parameters here. This is the client ID and client secret that we recently received from Google. We are creating the SecurityConfig class. It is a configuration class, as indicated by the configuration annotation. The Enable Web Security annotation enables the security configuration of the web application. We create a method that creates and returns a bin in the security filter chain. It configures the security filter chain. This method takes an HTTP security object as a parameter, which is used to configure various aspects of security. The main page is accessible to all users without the need to log in. All other requests require authentication. The application uses OAuth 2.0 for user authentication. The build method completes the setup. Next, I will create a user. I needed to record them in the database so that I can assign other objects to them. Since I am using MongoDB, I will add the document notation. It will have the following fields: ID, given name, family name, email, picture. Why exactly these fields? Because this data can be extracted from the token we receive after successful authentication from Google. The ID will be the ID from Google in string format. I will also add get resetters. We also need a user repository that will extend from Mongo repository. Now I will create a controller. I will simply call it start controller. Here, I will need UserService, which will contain the logic for extracting data from the token and writing this data to the database. It is not available yet, which is why it is red. The constructor injects UserService into start controller. The first endpoint is the login to the main page. As you remember from the security filter chain, this entry will be allowed for unauthorized users. The second endpoint is a protected area. Here, a redirect to OAuth authorization should take place. Inside this method, the addUser method is invoked, which we will create soon. Let's create the user service interface with a single method addUser. We create UserServiceImpl, which implements UserService. Here, we need to implement its method addUser. We will use the UserRepository since we will need to access the database. Generating the constructor. Let's take a closer look at the addUser method. Obtaining the current authentication. At the beginning of the method, the authentication object is retrieved from the security context using securityContextHolder.getContext. Get authentication. This is an object that contains information about the current user and their authentication. Authentication type check. It is verified whether the current authentication object is an instance of the OAuth 2 authentication token. This type is used if the user has authenticated via OAuth 2.0. Retrieving user data. Principles. If the authentication is indeed an OAuth 2.0 authentication token, then the main OAuth 2.0 user object representing the current user is extracted from it. This object contains user attributes provided by the OAuth 2.0 provider, in this case, Google, checking for the user in the database. Next, the user's attributes are extracted from the OAuth 2.0 user object. On line 31, there is a check for the existence of a user with that identifier in the database. The identifier is the sub-attribute, a unique identifier for the user. We cast it to a string because it is an object. If such a user is not found, meaning the optional user is empty and returns true, then we create it. With this, we have all the fields that we extract from the attributes. Besides sub, there will also be given, name, family name, name, which is the first and last name combined, email, and picture, a link to the user's picture. Then this object is saved to the database using UserRepository.save. If the user was successfully found or added, on line 42, the method returns a greeting message that includes the user's name, hello, and the given name attribute is used. Then, the handling of the absence of a token follows. If the OAuth 2.0 authentication token is not found, the method returns the message, no OAuth 2.0 authentication token found. So let's summarize. The addUser method checks if the current user is authenticated through OAuth 2.0. If so, it retrieves the user's data, checks for the user's presence in the database, and adds them there, if they do not already exist. As a result, this method allows for the automation of adding new users to the database upon their first login through OAuth 2.0. The application can now be launched. So now I will try to access localhost 8282 just in an unsecured area. We see here hello, which is what we expected, and now into the secured area secured. And here it is, OAuth 2.0 Authorization. I choose myself. I enter my password for Google, and here you see the consent screen. Here you can review exactly what the application will have access to. Okay, continue. And now we get hello Olga. This means that we have successfully authorized and saved the data in the database. If you found this video helpful, please like it.